Hello, in this video I'm going to talk about this standard compaction test question, which is the question number 3 of the compaction problem set. So in this question, the test results of a standard compaction test are given, and also the dry densities and water contents values have been calculated. So for the first part, you can plot these dry densities against the water content and then estimate the maximum dry density and optimum moisture content. And if you draw these values on a dry density versus moisture content plot, it will look like this. And then you can see from the curve, it goes to a peak value and then it goes down with the increase of water content. So the maximum dry density you can easily find from the curve. So that will come up as around 2002 kilograms per cubic meter, and the corresponding water content is your optimum moisture content. So your optimum moisture content will be around 9.8%. Part B of the question asks you to draw the 0% and 5% air voids curves. So these curves are actually important because they can be used to ensure that the test results are accurate. To draw these 0% air void curves and 5% air void curves, we need to do a bit of a phase relationship type calculation, because somehow to draw these curves we need to know some combinations of dry densities and moisture contents. So what you could do is we can actually select some arbitrary dry density values and then calculate the corresponding water contents. And for these calculations also we are going to assume 1 cubic meter volume. So therefore whatever the dry density value you select will be the mass of solid in that soil sample in a 1 cubic meter volume. And when you select some arbitrary values, you need to make sure that your 5% and 0% air void lines will still be in the same plot, that you have drawn your compaction curve. So if you look at this question, in your dry density values varies from 1800 to 2000. So I would select 3 points between 1800 to 2000 for the assumed dry densities. So as I said, the dry densities will be directly the mass of solid because we are considering a 1 cubic meter volume. So I select 1800, 1900 and 2000 as dry densities or the mass of solid. And finally what we need to calculate is the moisture content for corresponding MS values or the dry density. So we know that the moisture content or the water content is defined as mass of water divided by mass of solid. The mass of solid is straightforward, so somehow we need to calculate mass of water when the mass of solid is 1800 and 1900 and so and so. So therefore we need to use some phase relationship equations, and so usually this kind of calculations is easier when you do it in a table form. So from the MS values, since we know the GS value, which is the specific gravity of the soil, we should be able to determine the Vs, the volume of solid, which is MS divided by GS times rho W, which is the density of water. From the MS values, therefore we can determine the VS values in the next column, since we know the specific gravity. So once you have determined the VS value, and since we assume a 1 cubic meter total volume, you can determine the VV, the volume of voids, which will be 1 minus volume of solid, So the now you can determine the volume of water. So the volume of water can be calculated depending on how much air, air percentage you are considering. So volume of water can be determined from that, and then once you know the volume of water, we can calculate the mass of water, which will be density of water times volume of water. Density of water times volume of water. So, so now we can calculate these values one by one. To calculate the Vs, when the Ms is 1800, that will be 1800 divided by, so Gs value is 2.7, which is given in the question, times 1000. So that will be 0.667. And when it is 1900, it will be, if you do the same calculation with 1900 here as the Ms, that will be 0.704. And similarly, when it is 2000, it will be 0.741. Will be the those will be the Vs values, the volume of solids. And then you can calculate easily the volume of void, which is 1 minus Vs. So this will be 1 minus 0.667, which will be 0.333. Similarly here, it will be 1 minus 0.704, which will be 0.296, and here it will be 0.259. Now we can calculate the volume of water. So volume of water, to calculate the volume of water, you need to consider which are the percentage air voids within the soil. So since we are considering a situation where 0% air voids, so there should be only solids and water. Therefore, total void volume is now filled with water. So therefore, void volume is now equal to the volume of water, because we are looking at 0% air voids. In voids, there are only two possibilities. It could be the water filled in voids, or air. So if it is 0% air, that means the voids are fully filled with water. So therefore, your volume of water is equal to the volume of voids. So these numbers will stay same, 0.33, 0.296 and 0.259. And then second last column is to calculate the mass of water, which will be the density of water times this volume of water. So this will be, just multiply these values by 1000. Will be 333, 296 and 259. So now we know our mass of water, and then mass of solid is here, so we can simply calculate the water content. So 333 divided by 1800 will be 18.5%. And for 1900, it will be 296 divided by 1900, that will be 15.6%. And the 259 divided by 2000, that will be 13%. So now you know the Ms values, which are same as the dry densities and the corresponding water contents. So now you can mark these points, mark these coordinates in the compaction curve plot, and then draw the 0% air voids curve. Similarly, we can do the similar type of calculation to calculate draw the 5% air voids curve. So we can have the same set of columns. We know the Ms values, and then Vs, which is Ms divided by Gs times 4W, and then we have the Vv, which is 1 minus Vs, because we assume a total volume of 1 cubic meter. And this will be the VW, volume of water, and mass of water, which is the density of water times volume of water. And finally, what we need is the water content, which will be MW divided by MS. So the total idea of this calculation is to get at least 3 points to draw the 0% air void curve and 5% air void curve. So we need the dry densities and the water contents. And since I'm going to draw the 5% air voids curve in the same plot within the same range of same range of dry density values, I still select these 1800, 1900 and 2000. And the Vs values, so the Vs values can be calculated similar to the previous method. That will be Ms is 1800 divided by Gs is still 2.7 and your rho W is 1000. That will give you the same value as before, 0.667. And similarly you will get the Vs values 0.704 for 1900, and for 2000 that will be 0.741, will be same. And now your Vv values, the volume of voids 1 minus volume of solid will be 0.333, and here it will be 0.296 and 0.259. Now the volume of water. So in the previous case for the 0% air voids there was no problem, because since it is 0% air voids, so the total voids volume is filled with water, therefore the volume of voids was equal to volume of water. However, in this case our total void space is not filled with water, only 95% of the air voids 95% of the total void is filled with water, because there is a 5% air void. So we are considering a situation where the soil has 5% air voids. So therefore your volume of water is just 95% of this 0.333 values. That will be 0.283, 0.246 and 0.209. So that was calculated by multiplying these values by 0.95. And then similar to the previous case, we can calculate the mass of water by multiplying this volume of water by 1000, which is the density of water. So this will be 283 and 246, and this will be 209. That's the mass of water in 1 cubic meter volume when the air voids percentage is 5. So now we can calculate the water content, which is the mass of water divided by mass of solid. Mass of water is 283 when the mass of solid is 1800. That will give you 15.7% water content. And when it is 1900, the Ms is 1900, it will be 12.9% and 10.5 when Ms is 2000. So now you have another set of coordinates of Ms, which is equal to the dry density and the water content, to draw the 5% air voids curve. So now you can see this graph showing these two curves along with the compaction curve, and in this curve you can see that the 5% air void curve has been crossed by the right leg of the compaction curve, and it has not touched the 0% air void curve. So we know that 0% air void curve is something that we cannot achieve through this compaction test. Next part of this question asks you to calculate some soil properties like void ratio, porosity and degree of saturation for the optimum moisture content and the maximum dry density. So to calculate that one, so from the curve we know that our dry density rho d equals 2002, and the water content, the optimum water content is 9.8%. So these are from the curve, and then we need to calculate the void ratio, porosity and degree of saturation under these conditions. To calculate these values, we need to know the volume of water, volume of voids and also volume of solids. So therefore, we are going to start with assuming a volume of the complete total volume of 1 cubic meter volume, and under these conditions, for a total volume of 1 cubic meter, the rho d is defined as ms divided by v. So since our volume is 1 cubic meter, within 1 cubic meter the mass of solid you have is 2002, and then we know that our water content, the moisture content, is defined as mass of water divided by mass of solid, and from that we can determine the mass of water, which will be mass of solid times water content. Water content is 9.8%, which will be 0.098. So the mass of water will be therefore 196.2 kilograms. So that is your mass of water. So from that mass of water, we can easily calculate the volume of water, because a volume of water is always mass of water divided by the density of water. So the mass of water is 196.2 divided by 1000, which is the density of water. So that will be 0.196 cubic meters. So that is the volume of water in 1 cubic meter of bulk soil. And then we can also calculate the volume of solid, because we know the specific gravity of the soil. Volume of solids will be mass of solid divided by GS, the specific gravity, times the density of water. So the mass of solid, we know it's 2002 divided by the GS is given as 2.7 times 1000, which is the density of water. So this gives us the VS, the volume of solids, as 0.741 cubic meter. After we have determined the volume of solids, we can determine the volume of voids, because we know that we assumed initially total volume of 1 cubic meter. So the total volume comprises volumes of solid and volume of voids. Therefore, volume of voids will be volume of total volume, which is 1, minus volume of solid. So that will be 1 minus 0.741. So that will give you volume of voids as 0.259 cubic meters. Now we have determined the volume of voids, volume of solids and volume of water. From this we can actually calculate all these required parameters. First we go to void ratio, which is equal to volume of voids divided by volume of solid. So the volume of voids is 0.259 divided by volume of solid 0.741. That will be 0.35, and then we can determine the porosity, N, equal to volume of voids divided by the total volume. So the volume of voids is 0.259. So we assume a total volume of 1. So that will be 1. So therefore your porosity is 0.259. 0.259 is your porosity. Degree of saturation, which is SR, is volume of water divided by volume of voids by definition. So volume of water, as we determined before, is 0.196 divided by the void volume 0.259. That will be 0.757 or 75.7%. So that completes the answer for part C.